Tip Talks Education. Yeah, you're welcome. We are still proceeding with organic chemistry. We have recently discussed isomerism and finished it, and now we are going to the reagents. These are fundamentals, really, because we reach a time and need to write mechanisms. We need to understand why we write mechanisms, what should be a donating species, what should be an accepting species, why do they accept, why do they donate. These are all discussed under here. Reagents. We have basically got two types of reagents, and they are basically, we have nucleophilic reagents, and we have those that are electrophilic. We have those that are electrophilic. Now, we can start by discussing about nucleophilic reagents. And I want to say that these nucleophilic reagents are these are reagents which are electron rich. And either with a negative charge or a lone pair of electrons. Now, this lone pair could be, actually the best thing is to say at least a lone pair, meaning that you could have one or more than one lone pairs. Now, we are saying that nucleophilic reagents are reagents that are electron rich. When the electron rich, that means they basically react by giving out the electrons or donating the electrons. So that this electron-rich species could be in terms of a negative charge, or could be in terms of a lone pair of electrons. But never the case, if they have a lone pair of electrons or have a negative charge, then they have capacity to donate electrons to electron deficient species. Now, we have got types of still nucleophiles. Types. They are also further subdivided into two types of really nucleophiles. Now, the first type is the neutral. If we don't call it neutral, we can call it molecular nucleophiles. Can call it a neutral or molecular nucleophiles. Now, just like the word neutral says, once you are a neutral, then you don't have a positive charge, you don't have a negative charge. The same applies to molecular. And these are basically nucleophiles with a lone pair, with at least, because we have more than one, with at least a lone pair of electrons. These are nucleophiles with at least a lone pair of electrons, and during their chemical properties, they react by donating electrons to electron deficient species. I want us to take an example here. That if this is a nucleophile, it would have lone pairs, which it would donate to electron deficient species. And that is a property of nucleophiles. They are electron rich and therefore donate electrons to electrophiles, which are electron deficient species. Now this one I can call it electron deficient. Species. And species which are electron deficient will represent them to have a positive charge, because a positive charge is acquired as a result of losing electrons. Once you lose an electron, then the proton is the nuclear, remember proton is in a neutral atom. In a neutral atom or compound, number of electrons is equal to the number of protons. So once you lose one or more electrons, then you gain a positive charge by the virtue that the number of protons surpass the number of electrons in that atom. And then protons carry positive charge while electrons carry negative charge. So you become positively charged by the magnitude of the number of electrons lost. Meaning that if you lose one electron, you gain one positive charge. In other words, the protons are more than the electrons by one unit. That's what makes you have one single positive charge. So now this is just representing a nucleophile, and I'm saying that this is my neutral, really my neutral nucleophile. So they will always react by donating electrons to electron deficient species. Then we need to look at examples of these nucleophiles that are neutral, or simply called molecular nucleophiles. One of the best examples is water. Water is one of the best examples of neutral nucleophiles. And what is funny with water is that it has got two lone pairs on oxygen. So it can donate any, depending on the reactions that it really has to go through. Then another one is the ammonia. Ammonia is also one of the examples of the molecular nucleophiles. They carry no charge, but then they react by donating electrons since they have a lone pair. Another one could be an amine. Amine is just like ammonia, also have got a lone pair on the nitrogen atom. So they also react by donating that lone pair of electrons. It could be hydrogen sulfide. Possibly it can also have somewhat, it can also really donate, because the sulfur would also have a lone pair of electrons. And so many examples. These are just the most common, the most really accepted. They are really the most common accepted examples of nucleophilic reagents that are molecular. And if you're to be molecular, should not carry any charge, whether positive or negative, should not carry charge, but preferably should only have a lone pair of electrons. Now, after discussing very well about this type of nucleophilic reagent, then we can go to another type of nucleophilic reagent as well. Now we go to ionic nucleophiles. Ionic nucleophiles. Now, these ionic nucleophiles, just like the word ionic means ions. And remember, we said it to be a nucleophile. You should have either a negative charge or a lone pair of electrons. So when we say ionic, then we don't expect somebody to think of a positively charged ion to be a nucleophile. It really cannot be a nucleophile because it is really electron deficient. So these ionic nucleophiles are nucleophiles that carry nucleophiles these are nucleophiles which carry a negative charge. Strictly, supposed to be a negative charge. These ones typically carry a negative charge, and therefore they can use their negative charge to donate electrons to electron deficient species. Take an example. This is a nucleophile with a negative charge. It would donate it to an electron deficient species. Now, examples of these nucleophiles could be so many for as long as they carry a negative charge. For example, it can be this group. This group is called alkoxide. It is an alkoxide ion. Normally, we normally obtain that alkoxide when potassium hydroxide is reacted with an alcohol, and then the salt formed dissociated completely. The ion you get is normally called alkoxide. Take an example. If you react potassium hydroxide plus ethanol, we get this salt. Now, when we dissociate the salt completely, now this salt is what we generalize as alkoxide. Now, depending on the number of carbon atoms it has, is where we derive the name. For example, this one has 2 carbon atoms, therefore we call it ethoxide. We call it ethoxide ion. Now, suppose we had this. That one would definitely call it methoxide. So, but it's one of the examples of a nucleophile, and we basically use it during preparation of alkenes from preferably alkyl halides, depending on the class which they have, preferably tertiary and secondary alkyl halides. So that is one of our examples of ionic nucleophiles. The second example could be that ion, which is hydrogen sulfate. It is also really a nucleophile, and it can really donate its electrons. Or halides. Halides are also ionic nucleophiles because they have ions to really donate. It can donate this pair of electrons, which is here, to electron deficient species, and therefore it is a nucleophile. Then we can also have a hydroxyl group. This hydroxyl has this negative charge, and it is this negative charge responsible for donating electrons to electron deficient species. And so many others. We can stop here and then go to another types of reagents. Remember, we have so far discussed about nucleophilic reagents. And now I want us to advance and look at the the electrophilic reagents. Another type of reagent, number 2, is electrophilic. reagents. Now, these are reagents. These are electron deficient species which carry a positive charge and only react by gaining electrons. They only can react by gaining electrons. The electron deficient species which carry a positive charge and can only react by gaining electrons. Yeah. So examples could be, as far as organic chemistry is concerned, could be carbonyl carbon. Carbonyl carbon is really electron deficient. For example, we would represent it by this. Yeah, that carbonyl carbon is electron deficient. It will only react by receiving electrons from a nucleophile. That is the first example. The second example is a proton. A proton is electron deficient because it carries a negative charge. Then we can also have this neutronium ion is also one of the best